Hi, I'm Katie MacKenzie, and this is our Bioswale project. First, the problem. The problem is that Butte Community College put in a 5.5-acre impermeable surface parking lot. This created an irregular flow of water through the drains to Clear Creek watershed. To remediate this issue, Butte Community College put in a bioswale, but unfortunately the bioswale comes with issues of its own. Nutrients sink during fall storms and source during spring storms because the bioswale stores the pollutants. Our solution is to add a rice hull biochar to the bioswale, hopefully preventing pollutants from reaching the stream. Some of these pollutants that we can help reach the stream are dissolved organic carbon, phosphate, nitrate, and metals such as lead, zinc, and chromium. The goal of our project is to compare the environmental impacts of two systems, one being the existing system of the bioswale, and the second being our proposed system with the rice hull biochar additive. The scope of our system includes the function and functional unit. The function is to treat stormwater before it enters the nearby watershed. The functional unit is to treat stormwater runoff from one storm, which is approximately 100,000 liters. The system boundary is our inputs and outputs to the waterway. Our inputs include all of the construction material, such as sand, aggregate base rock, concrete, and HDPE pipe. The rice hull biochar will only be added to our proposed system as it does not exist in the existing system. Our system boundary includes the process that the water will take from the storm drain through the bioswale, eventually ended up in the waterway. We have our outputs to the waterway, which are different for the existing and proposed systems. The information that we will enter in our life cycle inventory data includes our construction, and as we said, the rice hull biochar will only be added into the proposed system, not the existing system. The rice hull biochar only has a lifespan of 5 years, so it will have to be re-administered every 4 years. 4 times every 5 years. Our life cycle inventory continues for our emissions to water. The existing system outlets to water and the proposed system outlets to water will be added to their respective life cycle analysis. The method that we will be using is Tracy. We will use Tracy to view eutrophication, global warming, and acidification impacts because we'd like to see that the impact that the bioswale has on the waterway. For our present worth, we will be doing a present worth analysis to view the expected cost over the course of the project's lifespan. As you can see from our economic impacts, we have a large initial cost with the construction and initial biochar additive, and every 5 years we have a replacement for that biochar. In order to calculate this number, we came up with a P given F formula to add the biochar replacements every 5 years, just added to our initial cost since that's already in present value. This came to a total of $101,613.71. However, the rice hull biochar is less than 1% of the cost of the project, most of this cost coming from the construction of the project. Initially, when we added our LCA results with our construction data, it was being completely overshadowed by our crushed gravel, so you could not even see the difference that our charcoal was causing for the emissions to the waterway, and all the graphs look exactly the same as they did priorly. In order to fix this issue, we took away the construction data since both of the projects have the same construction. We just wanted to look at their emissions to the waterway. As you can see in our eutrophication graph, our numbers decreased greatly for our pollutants. However, the charcoal did add a large amount of eutrophication itself. The total amount of eutrophication for the existing is about 3.3 and the proposed is about 3, so it does still go down. However, the acidification and global warming were non-existent before we added our rice hull biochar, and now it does exist due to this charcoal that we've added to our LCA. In conclusion, we believe our data is somewhat inaccurate because Simipro does not have rice hull biochar, so we did have to use charcoal, which is worse for the environment than our rice hull biochar because rice hull biochar is a byproduct of existing operations. So we do feel it has a large decrease in the pollutant load. And the cost is only 1% of the final project, so the cost is a very small amount of what the construction has already been. And you also only have to re-administer it every 5 years, so we do feel that this project is very practical. So after considering economic, environmental, and social factors, we believe this project is a viable solution to our bioswale issue. However, we do think that we need more information on the actual environmental impact of our rice hull biochar.